Have you ever pondered the intricacies of the objects that surround us daily? How their design and manufacturing processes contribute to their function and aesthetics? Well, buckle up as we delve into an enlightening exploration of various design processes. First, let's tackle design for casting. This process is all about creating objects by pouring liquid material into a mold, which then solidifies. It's a method that's been around for thousands of years, used in everything from jewelry making to automotive parts production. The key principles here include ensuring a smooth flow of material, proper cooling, and solidification to avoid defects. Moving on, we have design for bulk deformation processes. These are processes that use force to permanently deform a material, like forging, rolling, or extrusion. It's pivotal to consider factors like material properties, deformation temperature, and rate of strain in these processes. Next up is design for sheet metal forming processes. This involves bending and shaping flat sheets of metal into specific shapes. The design needs to account for the material's bendability, the bend radius, and the direction of bending to prevent cracks or distortions. Now, let's venture into design for machining. This process involves cutting away unwanted material to achieve the desired shape. The design must factor in the machine's capabilities, the cutting tools, and the material's machinability. Switching gears a bit, we have design for polymer processing. This process is about shaping plastic materials. It's essential to understand the polymer's properties, like its melting point and flow behavior, to design a successful product. Next, design for powder metallurgy involves making a product from metallic powder. The design process should consider the powder's characteristics, compactability, and sintering behavior. Now let's talk about the co-selection of materials and processes. Essentially, this is about choosing the right material and corresponding manufacturing process for a specific design. It's a balancing act between material properties, manufacturing capabilities, and design requirements. Moving on, design for assembly is about designing products so they're easy to put together. The goal here is to reduce the number of parts, design for ease of handling, and minimize assembly directions. Next, we have design for heat treatment, where the design must consider the effects of heat treatment on the material's properties. It's essential to understand how heating and cooling rates will affect hardness, toughness, and other attributes. Finally, design for reliability and quality involves designing products that are reliable and high quality. This involves techniques like failure mode and effect analysis, robust design approaches, and design for optimization. To summarize, each design process has its unique considerations and principles. From casting to machining, from polymer processing to heat treatment, understanding these fundamentals allows engineers to create products that are functional, reliable, and aesthetically pleasing. It's a fascinating world of design, materials, and processes where creativity meets science and technology.